Hey guys, BuildZoid here, and today we're going to be taking a look at this kit of RAM right here, and basically just the whole lineup, sorta. So this right here is Team Group's new T-Force Xtreem DDR4, and what you really need to know about it is that it is a new series of DDR4 from Team Group, and it's basically their like the highest end stuff they sell, targeted at overclockers, and basically right now it's a really good way to get your hands on some Samsung E-die or Samsung B-die based memory sticks. So the kits come in two sizes. You can either get 8 gig kits with 2 sticks, or 16 gig kits with 2 sticks also. So the 16 gig kits use 8 gig sticks of B-die, and the 8 gig kits use 4 gig sticks of E-die. Ugh. How is that so hard to say? It's not that complicated. Anyway, so you can get basically E-die or B-die memory ICs. The speed bins they offer are everything from 3466 all the way up to 4000, and it goes 3466, 3600, 3733, 3866, and 4000. Basically, if you get B-die or E-die is entirely tied to the size, as E-die is a 4 gigabit IC, whereas B-die is an 8 gigabit IC, so 8 chips of B-die make an 8 gig stick. The kits are pretty expensive, but it is really nice RAM. Like, it's basically, Team Group goes through quite a lot of B-die, or so I've been told by friends, as I don't really do that much memory testing myself. And the end result is that the Xtreem kits actually really end up with they really end up with the top of the best of the B-die that Team Group gets. My kit here is the 3733 variant with timings of 18, 20, 20, 39. That's not the lowest timings out there, but doesn't really matter for overclocking. And it's rated to run at 1.35 volts. I've tested my kit to work on Ryzen. If you're interested in getting some B-die for Ryzen, then yeah, this'll work. I do believe there might be some cheaper options out there, as unless you're going for a motherboard with, like, if you only just want 3200, 14, 14, 14, 34 timings on Ryzen, then you can get, there's other kits out there that are available at lower prices and lower speed bins that I think make more sense for that. But if you have a motherboard with like BCLK overclocking, and therefore you want a kit that can do like 3600 or 3733, which really is the top of what Ryzen can do, then, this is an option. That's really not much of a question about that. It's B-die. I've tested it on the Tai Chi. It runs 3200 really easy. So 3200, 14, 14, 34 timings, absolutely no problem getting that working. Higher frequencies, I've already showed you what I think of the Tai Chi BIOS, so I haven't been able to do any higher frequencies because the BCLK overclocking is right now completely broken. And testing with the BIOS in that state is a nightmare. So most of my testing with the kit, as far as actual overclocking capabilities go, it has been on Kaby Lake, so my Maximus 9 Apex motherboard, and I actually will be showing you how to get some really nice, the basics of how to get B-die performing well on LGA, Z270. I'll show you how to do that. But before we get into that, I wanted to show you some performance numbers. So we're going to look at the JDEC spec. So JDEC is the absolute bare minimum of what DDR4 is allowed to run at. The spec is either for 2133 or 2400. And we're going to look at performance in SuperPi 32 million because that's the most memory-focused benchmark I know of. Other benchmarks that you'd really want to consider B-die for would be like 3D Mark Physics. That gains a ton. Unigen Heaven, when you're really pushing super high FPS, it does actually end up caring about memory quite a bit. Basically anything with this heavy CPU bottleneck that isn't Cinebench will benefit from high-performance DDR4 a lot. And same goes for DDR3, actually. So You know, you really want a kit of BDI if you're going to be running SuperPi, Geekbench, XTU, what else was there? I think H.265 also, the hardware bought H.265, or is it H.264 benchmark? That one also cares. The 3D Mark Physics tests care. Unigen Heaven cares. I swear I'm missing a big one there. There's MaxMem read bandwidth. That's another one you can test for. So yeah, there's a lot of benchmarks which care about RAM overclocking. I'm just going to go through SuperPi because that's the really obvious one. And that's usually where a lot, like, that's the big one. That's the hardest one to actually run in terms of stability. 32 million SuperPi is quite a lot touchier than a lot of other benchmarks as far as memory stability goes. So let's check out the performance numbers I've managed to get out of this kit on SuperPi 32 million. So let's switch over to the monitor, and here we have it. So this right here is the ASRock timing configurator. This is just a utility so I can view all the different memory timings in Windows. So these right here are your primaries. This is usually what you'll see on the box of your kit. Then you have your secondaries. Well, these are referred to as secondary timings. Then you have down here the RTLs and IOLs. RTL stands for round trip latency. I'm going to guess IOL stands for IO latency, but I'm not entirely sure. RAM really isn't a big focus of mine. Then here you have what is known as the tertiaries. And actually, interestingly enough, this has been available for basically forever. It's available everywhere. On Ryzen, this is the only thing you can actually... On Ryzen, you only have access to these, like that. You don't have access to all of the different memory timings that you normally do on Intel. On Intel platforms, depending on which motherboard you have, you'll have access to that. And on more recent motherboards, like, well, DDR4, I think every motherboard actually supports it. You actually get access to the RTLs. So over time, you know, RAM overclocking has steadily been getting more and more complicated as motherboard vendors have been adding more and more access to memory settings onto their motherboards, because all of these settings exist, right? These were always available on the motherboard, but you usually didn't have access to them, and these are actually pretty important when really pushing RAM to its absolute limit, as I will show you later. So yeah, so this is bone stock, and as you can see, I'm running 5 gigahertz on the CPU, 4.8 gigahertz uncore or cache or ring or whatever the hell you want to call it. And the end result at, you know, JEDEC speed, so 21, 33, 15, 15, 36, is a time of 6 minutes and 37 seconds. So it's pretty damn slow for 5 gigahertz. Now, if I load up the XMP on this memory, it actually saves a really nice chunk of time. It saves about 16 seconds. You end up with 6 minutes, 21 seconds, so, you know, pretty big improvement. This is at 1.35 volts. This is just the straight XMP. CPU clock and ring clock are, you know, unchanged. So that's how I got this score right here. For timings, you can see that we have the 18, 20, 20, 39 primary timings, and everything else I left. This is all auto settings for the motherboard. Depending on what motherboard you have, everything except the primaries will actually vary from motherboard to motherboard depending on how the motherboard wants to run your RAM. So actually you can see some memory performance differences between motherboard to motherboard, even at XMP. The Maximus 9 Apex is widely regarded as one of the best RAM overclocking motherboards out there, so I don't think it would be underperforming whatsoever. And this is what it did. So, you know, save 16 seconds. Basically, you know, that's like a... SuperPi is one of those benchmarks where good memory settings can literally give you can give you the equivalent of a 200 megahertz core clock advantage. So, yeah, and this is not where it stops. So then there's this, which was just me messing around at 1.45 volts. It's not particularly complex. Like, I didn't really optimize this very heavily. You're looking at a CAS latency of still 18, 19, 19, 39 timings, running at 4,000 megahertz for the memory, still the same CPU clock and ring clock. I have tweaked the RAM refresh interval to 65,000, so RAM, well, I guess I should explain timings at this point because we've gone through quite a few of them. So for those unaware, memory timings really should, yeah, it makes sense that they're called timings, but they're not a fixed time delay. What memory timings are is a indication of how long in clock cycles it takes for an operation in the RAM to happen, right? So CL20, so cast latency of 20, which is column access strobe. So column access strobe latency of 20 is the same at 4,000 megahertz is the same as column access strobe latency of 10 at 2,000 megahertz. Effectively, they're the same. Though generally higher, like really high frequencies will actually get you extra bandwidth just because of how they interact with the memory system. So timings aren't everything. You generally want a good balance. I can clock this RAM a lot higher than 4,000 megahertz, but the timings stop going. Like, I can't get the timings as low. So here you're looking at a cast, at 18, 19, 39, 4,000, 1.45 volts. I never actually fully tested if it's stable at these settings. It did boot and it did finish SuperPi 32 million, which isn't really a stress test. If you wanted to stress test this, you'd use like memtest 86, and that would actually test the memory properly. But here I was just trying to see what I could do sort of, easy. And then there's this. This is a hell of a lot faster than JDEC. So this is bone stock. This is 213315 again. 6 minutes, 37 seconds, right? 5 gigahertz CPU clock, 4.8 gigahertz ring on-core cache clock, whatever you want to call it. And then we go to DDR4 4000. Timings of 12, 11, 11, 28, 1T. Custom secondaries, like manual secondaries, manual RTLs, manual tertiary timings. Everything is manually set. Admittedly not by me, because I'm a massive scrub at RAM overclocking, but the Maximus 9 Apex has memory profiles saved into the BIOS, and this one that I loaded up is the 4133 2 volts profile, Dancop 4133 2 volts profile. I'm running it at only 4,000 because I can't get it to run at 4133. Just because my the kit I have here isn't really capable of that. Most kits generally won't be able to actually run these settings even at 4,000. A lot of kits you're looking at only running this at 3866. A lot of motherboards won't be able to. Most motherboards aren't capable of running these settings at all, regardless of what memory kit you stick into them. So yeah, this is fast. It's up there. And compared to the, lax 21, 33, 15, 15 timings, this does 6 minutes, 6 seconds. So you save 31 seconds in calculation time on SuperPi 32 million by just tweaking memory settings. Because remember, my uncore is the same clock, my core clock is the same clock, my everything else is the same except the memory settings. So this is really, like, if you're going for SuperPi 32 million, if that's a benchmark you like doing it, you need good RAM, and this is a really good option. Yeah, so that is what you're looking at if you're going for maximum performance. Absolute maximum clock I got out of this kit so far is 4,500 right here. So you can see the timings. This is not actually that loose. I was having trouble getting, I tried to loosen out the timings further, and theoretically that should work just fine, but for some reason I was having issues with my kit. I still need to do more testing on that, but I did get 4,500 working, and I currently hold the record for the Czech Republic as far as RAM clock goes with this memory kit, which is kind of sweet. The big problem with running really, really high memory clock is that it generally ends up hammering the CPU's memory controller. Not the, it's not a problem of the memory kit or the motherboard or anything like that. I'm pretty much sure I hit the limit of the CPU. So if I want to go beyond this, the speed you see here, I do believe I'll have to put the CPU on liquid nitrogen, because as it is on the little AIO cooler, it just doesn't go any faster than this. which incidentally, I didn't even bother running SuperPi 32 million. And the main reason for that, it just doesn't make sense because the refresh cycle is awful. Refresh interval is awful. It's really, really short. The refresh cycle takes a month to finish. The primary timings are terrible. Like, I picked up 500 megahertz memory clock, but my timings are more than double what I was running at 4000. So, you know, this is why you don't see people benchmark at like 5 gigahertz memory clock, even though we can run 5 gigahertz memory clock. It's because 5 gigahertz memory clock sucks. You can't run it. Your timings end up so loose that any actual like work being done in the RAM takes a month to finish, and so the performance is awful. So nobody actually runs really, really high memory clock if they want to do like SuperPi benchmarking or something. So with that out of the way, let's go back to the camera, check out the kit, install it in a system, and I'll show you some tricks for getting it booting at really high frequencies. This might not actually be completely successful because I'm not a great RAM overclocker and this is really hard. Let's move the microphone so that you can still hear me, hopefully. I'm gonna have to shout here. So the system, ta-da! So this right here is of course my Maximus 9 Apex. The main highlight of this motherboard is the 2 DIMM slots. This is key for the fact that it can run the memory settings that it can. There's not many motherboards out there that can do these memory settings at all. Basically, as far as I'm aware, if you're trying to overclock a B-die, for DDR, like, for the timings I was running, so 12, 11, 11, 28, with most 4-DIMM motherboards, you're looking at about 3866. You're not really going to be going much above that. Very few 4-DIMM boards can do 4000, 12, 11, 11, 28, regardless of what kit you stick into them. Some 4DIMM boards are capable of doing like 4000, 12, 12, 12, 28, which isn't as difficult to do. And it's also a lot more common on B-die memory. 4000, 12, 11, 11, 28 is actually above average. So, you know, the typical sort of B-die hits between like 3866 and 4000 at 12, 12, 12 timings. So that's sort of like a generic kit of B-die, and good kits will go 4000 and up at 12, 12, 12 or 12, 11, 11, 28, like this one here. So these are the sticks themselves. Massive aluminum heat spreader on them, very heavy for a stick of RAM. You can see quite clearly that they are single-sided. So you have memory ICs over here and here. They're split into these two banks, which is actually kind of unique because usually you'd have them evenly spaced across the RAM. Not the case with this stick. On the back, you can see there's nothing under the heat spreader. There we go. See? No memory ICs on the back. So this makes this a single-ranked B-die 8 gig stick. B-die can be found also in 16 gig kits, but those don't clock as well just because they're too dense and put too much load on the memory controller. So let's get this installed and see what we can do. So right now the system should be bone stock in terms of settings. There's no RGB on the RAM, unlike the motherboard. You know, I think most people would actually welcome that, at least from what I've seen on the internet. I personally don't care. Let's fire it up. And I now haven't remembered what way. So, okay, I did get it wrong. Good. So I will be able to show you that B-die has a interesting little issue with when you're trying to run really high clocks. Hopefully it'll actually show up because I've gotten a lot better at overclocking this kit of RAM since I first got it. I've clocked in I think over 20 hours with it now. Just like trying to boot different settings, I've spent more than 20 hours. Run SuperPi and then try boot higher settings again. So, yeah, quite time intensive. I'll switch you to the BIOS view now. Come here. There we go. So now we're in the BIOS. We are completely bone stock, so I'll go load up a profile because I don't want to go through all the settings. So I do have a really nice profile here, but I'm not going to load that up. I'm going to load up profile 2, which is basically this one. We can see we're at manual, 5 gigahertz core clock. Automatic RAM frequency, so it's going to be 2133 right now. 1.35 volts core voltage, 1.22 VCCIO, system agent, 4.8 gigahertz cache ratio. So this is like basically the baseline I was using for all of my testing. DRAM timings, you can see, are all auto. And for some reason, people have a desperate need to keep messaging me. Mute. There we go. Ugh. So, first I'm going to check that it actually boots at 5 gigahertz. And then we're going to load up 4012, 12, 12, 28, and see if that works. It shouldn't work. Ideally, it won't work, but there's a small chance it will. So, because I couldn't get 4012, 12, 12 working before at all, but eventually, like, I figured out that, well, you'll see. Ideally, it won't work, and I'll be able to show you at 12, 12, 12. If it does work, then we'll just have to load up the 4012, 11, 11, 28 profile. So first things first, let's set our memory frequency, and I hate this BIOS. This is so awful. There we go. It's kind of laggy. I don't like that. It's a lot less responsive than what I'd like to deal with. So we're now at DDR4000. Time to dial in my voltage. This kit is nice because I can just put 2 in there, which is incidentally where the motherboard maxes out until you put the until you enable the LN2 mode. So the kit won't actually need 2 volts, but I've only ever managed to get it to pass SuperPi 32 million at 2 volts. So yeah, DRAM VTT 1.94, I think. Not entirely sure on that one. But basically, you have to set this voltage manually because automatically it will set it to half the DDR4 voltage. And BDI generally likes, if you're pushing like 4000 at 2 volts or, well, anything between 1.9 volts and 2, you're going to be looking at a VTT voltage, DRAM VTT voltage. Not to be mixed up with VTT voltage on some Intel CPUs. That's a completely different voltage. DRAM VTT is RAM termination voltage, and it's basically the voltage that is assumed, I do believe, I might be wrong about this, but I do believe it's the voltage equivalent to a binary 0 on RAM. So this is like the termination voltage. This is the lowest voltage your RAM will ever go down to on the signaling. Because if it actually had to go all the way down to 0, it would cause a horrific mess because it would pick up all kinds of noise. So BDI doesn't like very high VTTs, and it won't actually post with that. So generally, most kits will be between 0.85 and 0.975. So mine needs just under 0.95 in my experience. So we'll see if we can get that working. And actually, ideally, this won't post. So 12, 12, 28, 1N. And this right here, what I just did, will not post. And I'll actually show you. So we have 2 volts. I'm just going to check my settings. So we have 4000, 2 volts, 0.937 VTT, 12, 12, 28, 1T. Great. And now I'll show you the motherboard. And it will not boot. So we can see, and please don't boot. So it'll hang on the 4F code. This is normal for the BDI memory. With the timings I've just set up, it takes forever to boot up, regardless of if the settings are wrong or right. It just takes forever. But we got a 3F code. This tells me there's a lot of timings that aren't correct, and that's why it's not posting right now. So let's go into the BIOS and start setting some critical timings that are absolutely necessary to get 4000, 12, 12, 12, 28 working with this motherboard. I'm not 100% certain if these are absolutely necessary on other boards because I've never tested this memory on other motherboards, and I've never tested that much BDI anyway. And it decided it would not pick up my... Oh, no, it did get my keyboard. The board sometimes doesn't initialize my keyboard until it gets into Windows, which is rather annoying. So we're back in the BIOS now, and we need to go set up some key settings. Now, if you don't know what you're doing at all, try some of the memory presets. For Samsung BDI, you're going to be looking at new Samsung single-sided 2x 8 gig. That's what you want for BDI. This is the profile with which I got 6 minutes, 6 seconds on SuperPi 32 million. That profile is really, really nice. I did have to tweak the voltages, and I wasn't running it at 4133. So, Yeah, but we're not going to load up a profile. I want to show you how to do this manually because not all motherboards have the benefit of that profile. So your DRAM write latency, if you can find it in your BIOS, set that to 9. And this is only, I do believe it might work for 3866, but it's necessary for 4000 in my experience. The other timing you're going to absolutely have to set is TWRRD, SG, and DG. These two you absolutely have to set to 21 and 16. Otherwise, this will not post. And then you need to go into your RTL IOL control, which you have to set to 50, 51, 7, 7. And this should post just fine. So that's all you have to do to get 4000, 12, 12, 12, 28 working. Now back to the motherboard so that you can see how this normally boots up. So actually it won't boot. It still shouldn't boot because I have the memory sticks thingy with them. But and also sorry about knocking over the mic. It's right in like between my hands. So 55. So we got a 55 code here. It's not working. We'll try the retry button. This white button right here. That's retry. Basically it forces the motherboard to try my memory settings again without changing anything. And it will not boot. I guarantee it. Because the memory sticks aren't, like, 4F. The taking a long time to get through the 4F code, that's because of the 1T command rate, generally speaking. If you set 1T on any memory kit, it'll take forever to get through 4F. But the boot procedure for, like, the boot cycle for BDI is really, really weird for me, at least. It power cycles the board a few times. So it's still throwing a 55. I know exactly why that is, because I've labeled my memory sticks for a reason. So we can clearly see this stick has that. Can I get that? There. You can see that little mark there, which I don't have on this stick. There we go. So the reason for that is this stick has to go to the outer slot, memory slot, which I call slot 2. So that's why it has a little S2 on there, even though you can't actually tell that. So let's get the memory sticks in the right way around, and now it should boot, assuming that it doesn't load up safe settings. There. So that's... hopefully it still remembers my BDI set. Like, hopefully it doesn't decide to boot, say... yeah, it's booting safe settings. Doesn't matter. I'll just throw it into the BIOS. It's because I swapped the memory, because I hard shut down the system. And we're in the BIOS 2133, but it didn't wipe my settings. So I'm going to still just go F10 and say, and let's go back to the boot up procedure, because this is the thing that, like, is really weird when pushing these really high memory frequencies. So you'll hang on 4F for a bit. That's fine. That's normal. Then it'll go 32, 35, 37, 22, 4F, 60, shuts down. That's completely normal. It'll do this several times before any startup at the settings I just dialed in. So we get to hang on 4F again, and it does this twice, at least twice before booting. Sometimes it will refuse to actually boot all the way, so then you'll have to hit the retry button some more. Which, the problem with this is, if you have a new kit of untested BDI, it's really hard to figure out if you're just bad at memory overclocking or if the kit is bad. That was my initial problem, is like I couldn't get it to boot 4000, 12, 12, 12, 28 to save my life. Like, if somebody told me that I have an hour to get it to boot these settings that it's booting right now, which just worked, V2, good job. Made it. Now it actually posted, and I'll take us all the way to Windows, hopefully, unless my... yeah, okay, my automatic tap on the delete key did get us into the BIOS, but no matter, we can just hit escape and quit without saving, and that'll throw us into Windows. And here comes Windows 10. What a lovely operating system. And bam, we are now in Windows 10. And we can check all of my memory settings right here with AstroRock Timing Configurator. So now you can see it actually did boot up 12, 12, 12. 28, 1T, just fine. And then we have the RTLs down here of 50 and 51, 7, 7, and this 21, 16, and the TCWL of 9. So those are the absolutely critical timings for on the Apex, as far as I'm aware. I checked with a few others, and they told me, yeah, that's completely normal. You absolutely need this for BDI. So yeah, and it'll just crash like this a lot. So what we're going to do now is we're going to safe boot. So I just press the red button next to the white button on the Apex. That's the safe boot for this board. It'll boot us in with completely bone stock settings, and I actually wanted it to crash. So that's a win for me here. Because there's one thing I still haven't set in Windows. So we're going to go all the way to Windows now, and I should have been... I just have a bad habit of just mashing the delete button with this system. Just like, oh, the system's booting, delete, delete, delete. But we're going to go into Windows, and we need to set something. Otherwise, the BDI will never be stable. Just, this is a issue with BDI memory specifically, not DDR4 in general. If you're trying to run these really, really hard settings, like 4000, 12, 12, 12, 28, you need to go and set the max mem. Otherwise, it will just crash randomly before you can do anything. So, here we have the system configuration. I can't remember how to get to this window, which is why it's on my taskbar. And you'll go to boot, advanced option, maximum memory, and you want to set below 4 gigs. I generally use 1,200 megabytes. And we just go apply, okay, exit, restart. And now because I used safe boot to go into the operating system, it should boot us in at the 4000, 12, 12, 12, 28 settings. Man, this video is long. I mean, I knew it was going to be long because memory overclocking is slow and painful, but I really hope there's no errors in it. So yeah, and now it's going to do the BDI boot loop. It might even fail to boot sometimes. Actually, I'm going to go and load up the DANCOP profile, because sometimes you can just press the white retry button through quite a lot of different memory errors. Like you'll get a bunch of postcodes which are telling you, oh, it's not booting, but you can just keep pressing retry, and eventually, like, as long as you're not getting like 55 or 49 repeatedly, just over and over and over, but you're hanging on, say, like, I crashed on 78, which is just like BIOS, like, which is, I do believe, like boot device initialization or something. It's really, really close to the system finally coming online. So if you're hanging on like 78, 96, or B2, you can just retry through that generally. And you might want to go and tweak your voltages a little bit because you're just below the edge of stability. So, yeah. RAM overclocking, very difficult. That's why I don't do much of it. So, we are now no. Okay, we made it. I was worried it hanged on us right there, which also happens. It just hangs randomly all over the place when you're running these kinds of settings. So let's get into Windows 10 again. Now we're on a lot less memory, and now it'll be at least semi-stable. It might not be quite able to pass SuperPi 32 million, I don't think. But, it might give us like a rounding error, but it shouldn't give us a straight blue screen. I maybe shouldn't have run 32 million, because 32 million takes 6 minutes. But, and right now the sub timings aren't optimized, so this time will actually suck compared to the time I showed you before. So it's going to be like 610 or something instead of 6.6, like it was with the DANCOP memory profile. Huh. You know what? If you're watching this, just press the speed up button, I think. At this point might be a good idea, if you haven't already speeded up the entire video. Actually, you know what? We'll just... I mean, I don't really care about this actually finishing properly. So, yeah, there you see all the timings. CPU-Z. And as you can see, it's now a lot more stable. Before, it basically crashed instantly. So, max memory is absolutely key to getting stability on BDI when you're running really, really high aggressive settings. When I'm running that DANCOP memory profile, which is like 12, 11, 11, 28... and all of these subtimings are like optimized for maximum performance, that one I sometimes just have to retry a few times before I get into the operating system and actually pass SuperPi 32 million, because it'll just randomly crash, and just restarting tends to fix that, which I know that's awful, but it works. That's about the end of my care. That's basically the reason why don't focus so much on memory overclocking. It's just a case of I need to be able to get by. I don't need to break world records on it. But yeah. So I think at this point, you know what? We'll just cut it here because I don't think you want to watch SuperPie 32 million finish. It takes forever. And I already showed you the scores at these at better settings than this, so you know, it's not really like a trust issue here. But yeah, you have to set max mem. You have to do the like cast write latency and TWRRDSG and TWRRDDG. You have to set those to 21 and 16. And I think that might actually be all 2DIMM motherboards, and the RTLs are almost certainly specific to 2DIMM motherboards. So, yeah. So that's sort of what you need to know about overclocking B-die memory. The cool thing is, if you're running higher cast latencies than, like, if you're running primary timings that are higher than this or lower memory frequency, you can still set everything except the RTLs to the 9, 21, 16 thing. You can still set those up. The RTL timings, this one, and the IOL timings, those are frequency and cast latency specific, so you can't just set them for whatever. I tested that, and it changes, like, what works changes very specifically depending on memory frequency. Like, these same timings at 3866 would require a 49 here and a 50 there, and a 6 and a 6 here. So, yeah. That's that. And if you know, the cool thing is, if you're ever overclocking memory on Ryzen, you don't have to worry about all this other stuff because you only have access to the first 4 timings, and so you can't actually do 4000 because there's no way the board is going to load up the very specific settings that you need. But also Ryzen currently can't go over like 3700, or well, 3800 I think is the absolute maximum somebody got at decent memory timings. So yeah, and actually SuperPie is past halfway. So I'm considering, you know what, since we're just gonna wait for SuperPie to finish, I'm just gonna talk about things I'm considering for the channel. I'm considering for the that I'm gonna do like a overclocking RAM on Ryzen guide without BCLK, because BCLK, as I said on the ASRock Taichi, doesn't work at all, which will be just a case of me sticking this memory kit into the motherboard and then loading up 3200, 14, 14, 14, 34. It's really not that hard. That boots basically instantly if you have a good kit of memory, which is, you know, nice. And which incidentally, that pretty much confirms that these kits, the Team Group T-Force Xtreem kits, are all Ryzen compatible as far as I'm concerned. I think they all use the same PCB for the actual memory sticks, which that does actually change motherboard compatibility, like how the memory sticks are laid out and what the manufacturer does for like SPD and stuff does change how compatible the memory is with different motherboards. So I think these kits should be all perfectly compatible with Ryzen. I do want to get in some other Ryzen motherboards to test with, just to make sure, but for now I'm going to say that, like, if you want, you know, this is an option. I'm personally really happy with the kit, and I'm going to be using it a ton. It's going to be basically on all the live streams, mainly because this is the only good kit of RAM I have. So huge thanks to Team Group for providing it to me, because otherwise I'd be stuck on Samsung D-Die that does 3700 at like 14, 19, 19 timings, which is atrocious. And look, SuperPie might even finish. So yeah, if you're, you know, interested in getting a very high, like a high performance kit of DDR4, look for this stuff, because it's good. And, you know, it works on Ryzen, it works on Kaby Lake. I'm considering personally to buy 2 more sticks to run on X99, and then, well, we all know X99 has a successor, and it will have a competitor. Hint, hint. Well, the successor of X99 will have a competitor. So, hint, hint, that will need more B-die. So I'm considering getting another kit Not necessarily the same kit here, but just another kit of B-die to run, you know, 4 sticks of this stuff. And then I might get rid of get rid of the D-die kit I have. And B-die is just about to, I mean, Super Pi is just about to finish. We're on the very last loop here. So, yeah, so I'm considering getting better RAM, considering getting another Ryzen motherboard to test, you know, compatibility with this kit. Probably actually do some proper overclocking on that motherboard, because that one, you know, hopefully won't have the same glitch the Tai Chi has. It isn't an ASRock board, so I'd expect it to have some like some other horrific BIOS bug that makes it completely unusable for at least another month. But, you know, I can still try. And, yeah, so that's sort of stuff coming up. Why can't this run sooner? Did it crash? No, it didn't crash. It's fine. Where's my loop 24, damn it? Yeah, but, you know, I'm really happy with this kit right here. You know, I think it might have crashed. Oh, yeah, it did. It just didn't show up. Not convergent in square root. Oh, damn it. That was so close. Oh, well, let's pack it up here, hey? So, thanks to Team for this lovely RAM. And I really do like it a lot. I mean, it's really nice. Did it get hot? It didn't even get hot, and it's at 2 volts right now, so... yeah. Testament to the giant aluminum heat sinks on those. I'll just shut the system down, and, yeah, that's it. So, thank you for watching. Like, share, subscribe, leave a comment down below, and, do consider donating to my Patreon or PayPal or buying an AHOC shirt or all of those things. And with that said, thanks for watching and goodbye. Just gonna find the stop button.